topic. Today we're going to have a look at the topic of electrolysis. Now this often frightens a lot of students, but in fact it's really quite simple, and it works as long as we remember some simple things and some simple diagrams. So let's have a go and look and see what we need to do. For this, what we need always will be some sort of battery. This is connected to two electrodes, and these are in some sort of container, and we fill this up with either a liquid or a molten substance. Looking at the battery here, it's labelled positive and negative. So our electrodes, the negative side electrode here is called the cathode, and the positive side is called the anode. So this is our basic setup, regardless of what we want to have a look at. So let's have a look at a particular substance and see what we can do with this. So let's take something like lead bromide. So I've got here my lead, Pb2+, and my bromine, which is Br-. Now this is just a solid, and ionic solids won't conduct. So what we need to do is apply a lot of heat to this until they become molten. And once they're molten, then we can do all sorts of things with this. Now, what we need to do really with this is have a look and see what is going on. And to do this, what we're going to do is we're going to have a little look at what's going on about here on the cathode. And what I'm going to do is I'm just going to draw that a little bit bigger. Right, so I thought I'd use a compass to make my life easier, and it didn't. So what we've got here are lots of electrons moving around, and they get stuck on this cathode. And in our solution here, our molten liquid, I've got some lead 2+ ions, and these are attracted to the negative because of opposites attract. In the same way, if we look on this side of the circuit over here, then what we can get is a slightly better circle drawn. Here's the electrode, and we've got a lack of electrons here. They're all disappearing, which is leaving this side to be fairly positive. And this will attract the negative bromine ions to this. So let's have a look and see what happens over on this side. The lead ion comes across and it picks up 2 electrons, and as it does so, the lead ion will be turned into a lead atom, Pb0, and this is now molten lead. So this molten lead will start to accumulate on this electrode, and will probably start to form a little heap down the bottom as it runs off. Let's have a look at the other side, the anode. What's happening here? Well, as the bromide ion approaches, it then donates an electron and forms bromine. Charge is going to be 0, but this is a gas, and it's a diatomic gas. It is bromine 2, Br2. So if I've got 2 bromines here at the end, I must have 2 at the beginning. And if one gave 1 electron, then 2 will give us 2 electrons. And so bromine gas will be formed here at the anode, and being a gas, it's going to bubble and be given off. And this is why I'm not doing this experiment, because I don't have a fume cupboard at the moment here, and without a fume cupboard, then this bromine, which is toxic, would go into the atmosphere and certainly wouldn't do me any good, and probably not anyone else. What's going on? Well, we know in a circuit the electrons travel. Electricity goes from positive to negative, but in fact the electrons travel along here from negative to positive. Now, as far as the circuit is concerned, electrons are disappearing at this point and are reappearing at this point. So as far as the circuit can tell, if it were alive, I suppose, could think about it, it could see that electrons were travelling all the way around. They're not, in fact. Electrons are travelling here. Ions are moving then in this solution, transferring or allowing electrons to be moved from one side, or appear to be moving from one side to the other, so that the circuit is complete and the current flows. So this is a fairly standard sort of circuit. We've got this set up, and this is what's happening, and these are what we call our half equations. Let's have a look at, rather than do this with a molten substance, let's have a look and see what would happen if we do this with something that's dissolved in a liquid. It's not very different, because what we have is basically the same setup. I have my battery. This is connected to 2 electrodes, and this is in a container, and we have in here our solution. And that diagram looks exactly the same as the diagram I drew a moment ago for something that's molten, but this time this is aqueous. It is dissolved in water. This side is still the negative, this side is still the positive, this side is called the cathode, this side is called the anode, and this time we'll have a solution of something in here. So let's dissolve some copper chloride in here. It's in water, so as well as having my H2O, this is going to break down and give me some hydrogen ions, some plus ions, plus some OH minus ions. The copper is 2 plus, the chlorine is 1 minus. And so these are all the things that are in the solution. Copper ions, chloride ions, some water, and some water that's also been ionized. What this means is if our cathode is negative, which it is, the positive items will be attracted to the cathode. So 2 items will move there. And at the anode being positive, then the chloride ion, but also this hydroxide ion will be attracted to this electrode. So let's have a look at what is going on at this cathode. And to do this, what I'm going to do is we'll try and draw a little circle and show what's going on. I'm not doing very well with my compass at the moment. I've got my electrons on this side, and here we'll have our copper 2 plus ions, but also some H plus ions. Both of these will be attracted here to the electrode, but you probably remember the reactivity series. And remembering this reactivity series, you'll remember that the hydrogen ion is more reactive than the copper. So in this respect, hydrogen being more reactive wants to stay in the solution. And so this hydrogen will basically stay in the solution, which means our copper will not. So our copper 2 plus will pick up, because it's 2 plus, 2 electrons, and what will happen is it will make copper metal, which is not charged, and this copper metal is normally going to be stuck onto the electrode, and this is going to be basically electroplating. I am going to weld on these copper atoms to this electrode. Let's see what's going on the other side. So if we look on the other side, I'll try and draw a bigger circle this time. What we've got is our electrode. These electrons have been taken away, so this side is fairly positive, and that's going to attract the chloride ion and the hydroxide ion. Now, we don't have in the same way a reactivity series for the negatives that we've learnt, but in fact there is one, and it's something called the electronegativity. And that puts the fluorine and the fluoride the most electronegative, the next most is oxygen, and then the next most is chlorine. So this is our reactivity with the fluoride, the fluorine, the most reactive, then oxygen. So oxygen is more reactive than chlorine, so the hydroxide with its oxygen stays here in the solution, and the chlorine is the one that has to react. So what happens here? Well, the chloride ion comes along, it gives up its one electron and forms chlorine gas. So it's an element, so it's not charged, but chlorine gas, like bromine gas, is a diatomic gas, Cl2. So if there are two of these chlorines here, there must be two chlorines at the start, and two chloride ions gave me, well, one gave me one electron, so two will give me two. And there is my balanced half equation. Let's look at one more, but this time we'll have a go at doing the experiment and we'll see what happens. So in all electrolysis systems, what we have is our battery, and we're going to connect this up to two electrodes in a liquid. Now in fact what we're going to do is something very similar to this, but we're going to change it round a little bit. And what I'm going to use is a little tube like this, and I happen to choose a dirty one. There we are. So I've got a tube, and what I've got here is a little bung with two carbon electrodes in it and a piece of plastic. I'm going to fit this in here, and I've got two electrodes. They're different lengths, and I found this to be beneficial. When these are supplied to me, they're supplied like that, and I find what the students do is they connect their circuit up, and what they do is they put this one on here, and they put the other one the other side, and they touch and nothing happens. Better with this system, then we set one on one side, there's a piece of plastic insulating this, and a piece the other side, and the two don't touch, and there is my little electrolysis tube. Now why is it this way up? Well, it's this way up so that we can collect, if necessary, any gases. And I've got here a couple of test tubes. They're very small test tubes, and these test tubes fit over these electrodes like this. And therefore I can now collect any gases made with this type of system, and it's quite effective at doing it. Let's go over to the experiment and see if we can set this up. So this is my experiment. Rather than use a battery, I've got here a power supply, and when I use this I'm going to set the voltage around about 3, maybe 4 volts. So I'm going to set that down here because I don't want to put too much electricity into the system. we're going to take this little cell. I've made sure that I've pushed this in firmly, not too hard so I break the glass, but firmly enough because I'm going to pour liquid in here, and as I pour liquid in here I don't fancy getting any on my feet. I'm going to hold it just tight enough in here. Now we're going to look at the electrolysis of a couple of liquids, and the first of these we're going to have a look at is sodium sulfate. And what I'm going to do is I'm going to pour some of this solution in here. I need to put in enough that I am just going to cover these electrodes down here. I don't need to have a whopping great amount. And then what I'm going to do is I'm going to put these little tubes in place. And so what I'm just going to do is I'm going to take a small beaker and let's do the filling of the tubes. This usually fools students how to do this. I'm going to do this over a beaker so that any spillage won't matter, and what I'm just going to do is I'm going to fill this test tube up with water. This actually it's not water, it's sodium sulfate, and I've taken it so it's just full, and you can see that it's here. We've got a positive sort of meniscus there. I do happen to have an air bubble in here, that's just bad luck. And what I'm going to do is put that in here, and to do that all I'm going to do is tip this upside down. And amazingly, when I tip it upside down the water doesn't come out, and it doesn't come out simply because this test tube here, this little mouth, is so narrow that the liquid can't get out. Let's do the other one. Any liquid that's spilt is kept up in the beaker, and then I'm going to quickly turn this upside down. No liquid was lost, and then what we're going to do is we're going to pop this one the other side and put this one over the electrode. Now what I want to try and do is I want to, down the bottom here, and I'm going to turn it very slightly so you can see it perhaps a little bit better. I have lifted the test tubes up a little bit so that they are not right at the bottom. So if I put them over, they're not quite at the bottom. If I just plonk them down, this is going to stop any electricity flowing, whereas if I can hold them up a little bit, then it's going to make life a little bit easier for the reaction to go. How can I hold them up? The answer is generally quite easily, and we can often do that with something like an elastic band. There we go. So the elastic band's just holding it up so it's not resting on the bottom. Right, we'll move the things out the way. I've finished with my solution, so I'll put that one safely at the back. And I need to know which one is going to be positive and which one is going to be the negative. So I'm going to use the short one as the negative, and I'm going to do the long one as the positive. And we put this in and we leave this for a moment to see if anything's going to happen. And we see soon enough something is starting to happen. On the negative side, I'm getting quite a lot of bubbles appearing, and these bubbles are going up the test tube and collecting in the top. In the other one, I'm not getting as many bubbles. I am getting some bubbles, but not as many. So I seem to be producing more bubbles on one side than I am on the other. Although I do seem to be making some. Well, let's leave this for a few moments to see what's going to go on. And whilst that's happening, let's have a look at this circuit and see what's going on. I drew this one this way, but in fact this one is going to be done the other way up. So I've got my tube. In my tube I've got a couple of test tubes, and inside here, that's my son just knocking something over, I've got two electrodes, and these are in fact off the ground a little bit, the test tubes. These then stick down the bottom. We've got a piece of card in here, and I've got one that's long and one that's short. These are connected to my battery. The short side I've made is the negative, and the long side is the positive. So this one is really round the other way than the one I did here, but that doesn't matter because this is the positive, the long one here, so this is the anode, and the short side here is the cathode. Whether you draw it like this or whether you draw it like that, it doesn't make any difference. In our solution I've got some sodium, Na+, some sulfate, SO4-, and I've got some hydrogen ions, and I've got some hydroxide ions from the water. Let's see what's happening. If we look back at the circuit, then we can see that we are starting to collect quite a lot of gas on this side. And on the other side, I'm not really collecting an awful lot. Just got a few bubbles up there. So we're getting something on the negative side, a gas. Let's have a look at what that gas might be. If we have a look at what could be going on this electrode, let's just zoom in and have a look at that. I found the problem with my compass. I've tightened it up. Let's see what's happening on the cathode. So on the short side, I've got lots of electrons. These are going to attract the positive, and we've got sodium ions in here, and we've got hydrogen ions. If we remember our reactivity series, then we know that sodium is nearly at the top and hydrogen's a fair way down. So sodium is more reactive, so sodium will stay in the solution and the hydrogen will here react. And if we look at the equation that's going to go on, I've got a hydrogen ion, it's going to meet one electron, and that's going to form, we know, hydrogen gas. We can see this being given off as a gas. Well, if it's being given off as a gas, then we know it's H2. If there are two of these here, there must be two this side, and that will meet up with two electrons there, and so this is my half equation for this side. Now, if this is hydrogen, then there is a way of trying to look and test to see whether we've got hydrogen, and that would be our Squeaky Pop Test. Now, this doesn't work necessarily terribly well. It doesn't because I basically haven't got very much hydrogen in here to collect. But we'll have a go. So I'm just going to switch the power supply off and I'm going to have a look and see what has happened. Well, I definitely seem to have got some gas in here. Whether this will work or not, I don't know. So let's see if we can get the liquid out. And I was a little bit slow, but we didn't have much hydrogen in here, and so my squeaky top test, I'm afraid, didn't work. I didn't have enough oxygen in there to work, hydrogen in there to work. On the other side, I've got very little has happened here. I'm trying to empty this test tube. Shows how difficult it is to try and do this. What I'll do is I'll do it over a beaker and get a bit more force on it, and there I'm ready to clear up. Disconnect my terminals, they are switched off, and you can see that this has gone a bit mucky, and now I can clean this out so I can do another experiment. I'm going to try one more. You'll notice I didn't really tell you what happened at the other side. I've got a sulfate group and it didn't seem to do very much. We'll have a look at this one though, which is sodium chloride, and we'll see what we can do with this. The setup is the same. What I just need are some clean electrodes, so I'm going to quickly swap this out with another one. I've got my long and my short side again, and this time we're going to use some sodium chloride solution, and let's put some sodium chloride in here. Just enough to cover the electrodes, and let's put some sodium chloride in here. You can turn it over quite easily. Put it over the electrode, and we'll do the same with the other side. I know my hand's in the way, I'm sorry, I can't do it the other way around. Turn it upside down, it stays, and what we're going to do is put this one over this electrode. And this one is a little bit tighter, and so I don't actually need the elastic band on this one because the tubes are held. Move our liquid out the way, make it safe to start, and to my long side I'm going to connect the positive, to the short side I'm going to connect the negative, and let's switch on and see what happens when we put about 3 or 4 volts through the system. Well, I have to say, not an awful lot here really. I'm expecting to see something happen. Just checking I've got good connections, which I didn't. And there we've got the reaction going. I'll turn the voltage down a little bit, so it's going a bit faster than I wanted. And we're getting something happening. On both of these we're getting some gases produced, and I can smell here some of the gases being produced, and what I'm going to do is I'm now going to stop this, and the reason I'm going to stop it is I know what gas is being produced in this little one, and I don't like it very much. So let's have a look and see what's going on in this setup. So if we draw out our diagram again, and we'll see what happens. Now I'm going to draw it the wrong way up. It doesn't really matter. You've seen what the solutions really look like, but I'm going to draw it this way up because it's an easy way to do this. I've got my container, we've got my 2 electrodes, and I am actually collecting the gases here. In the solution I've got sodium chloride, Na+, Cl-, and I've got my water, which is also going to be made of H+ and OH-. Let's have a look and see what is happening at each of these electrodes. This side is the cathode, the negative, and in my solution that meant it was the short side, and this one is the anode, the positive, the long side. Let's have a look and see what's happening here. So I'm just going to draw myself little circles to represent what's going on in the solutions. This side I've got lots of electrons. On the cathode the electrons have gone, leaving me positive charges. Let's look at what's happening on this side. The sodium Na+ is attracted here, as is the hydrogen. As we saw last time, the sodium stays in solution and the hydrogen here comes along, picks up an electron and produces hydrogen gas. H2, there's two of these, there's two of those, and this hydrogen gas is given off. So we can see at this cathode hydrogen gas being given off. On the other side we've got the chloride ion and the hydroxide ion. From our reactivity we know that the hydroxide is more reactive, so it stays in solution, and our chlorine is sacrificed. The chloride ion comes along, it gives up an electron and forms chlorine gas. Two of those, therefore must be two of these, and two electrons. So this side, chlorine gas, is given off, and that was what I could smell. So looking at our setup here, on my negative side we've attracted the hydrogen, and so I've got some hydrogen gas in here, a small amount, but really a bit too small to try and test that. And on this side I've got some chlorine gas, and here you'll see, so I'll try and put my camera finger where the camera was pointing, I've got a very small amount of chlorine gas, and I haven't bothered to do much. We could test that, and the way that we would test that is by testing it with something like litmus paper to see whether it will be bleached or not. Although, to be quite honest with you, you'll probably realise that it's chlorine because of the smell, and that is only with a very small amount. So I've taken the equipment away, and that's now ready all to be washed up. So electrolysis really is quite simple. It doesn't matter whether we're doing molten or aqueous, it's the same diagram. With molten, we've simply got to put in heat, and we don't have to worry about water. So if I did this same experiment with sodium chloride that was molten, then what I would expect here, if I did this again, same diagram set up, becomes really quite quick and easy when you've mastered this. If I've got sodium and chlorine, this time as molten, then it will be the sodium that's given off, and it will just be the chlorine that's given off. So sodium will here be molten, and we'll make some molten sodium at the bottom here, and the chlorine will be given off as chlorine gas. And this way we can make many of the very hard to get materials. We can make sodium metal, aluminium metal, magnesium metal, and many of these are made by electrolysis. In aqueous solution, then we have to worry about the water as well, and in this case the chlorine's given off, hydrogen's given off, and what we're left with is sodium hydroxide in the solution. And this is really a very useful reaction because it makes three things. It makes hydrogen, which could be used as a fuel. It's often, because it's very pure, used in food production, turning oil into margarine, vegetable oil into margarine. The chlorine, yeah, we know where that smell comes from, pools, and it's often used as a disinfectant or in pools for killing off the bugs. And the sodium hydroxide, that's also really useful because we could use that as oven cleaner. So a very useful sort of reaction. Now, when you come to do this as experiments, this is in fact one of those core experiments that often are done. So it's one of those experiments that you must do, and I'll put a link at the bottom to one of these experiments that I've already done, this electrolysis, so you can see all of this done. So electrolysis, really useful, and you can see that we've done a lot of the work here, but also I've got some links to help you look at some of the experiments I've done previously. If you found this useful, you can give it a thumbs up, and you can subscribe. That'd be very nice. And I will see you next week when we'll look at some more GCSE Chemistry, topic by topic. Stay safe. Bye bye.